Hey guys, we'll be doing some questions on free fall right now that we just learned in the previous lecture. So I have a question for you right here. Let's see what the question says first. An object does free fall motion. Okay, so first of all, we have been told we are being told here that the object does free fall motion. It hits the ground after 4 seconds. So it's hitting the ground after 4 seconds. It's been dropped from some place. Calculate the velocity of the object after 3 seconds and before it hits the ground, the final velocity. So let's see. We are doing free fall here. Example of free fall. Here, just feels good, right? The heading. Okay, so let's see. This is the situation here. This is the object that is being thrown down to the ground, and they have told us that this is free fall case. So this is free fall here. So first of all, what you should be making up out of this is that since it's having a free fall experience, the gravitational acceleration or the acceleration of this box would simply be g, which means a 9.81 meters per second square, or sometimes they also specify that just assume g to be 10 meters per second square. So in those calculations, if they have already given you the value of g, you take that specific value. If they haven't, then this is the precise value of g, which is 9.81 meters per second square. But just to make it easier on your level, they give you a 10 meters per second square. But the point is that this object, whatever this object is with a mass m, this object is going down with an acceleration equal to the gravitational acceleration, since it's free fall and there is no air resistance. So it's just moving with free fall acceleration. So you can see the limited amount of data we have. We only have that the time is 3 seconds, and we have to find the velocity of the object. So it's pretty easy since you know some of the formulas. So you know that the acceleration is 10 meters per second square, and the initial velocity, let's say it's v1, it's being dropped from rest, since the initial velocity is 0 because initially it had no velocity. So you know that the formula for that relates velocity and acceleration is very simple, which is acceleration is equals to v final velocity minus initial velocity divided by time. We have the time, and we know the gravitational acceleration, and we also know the initial velocity. So let's just change the color of the chalk here, just make it brown. So let's just solve the question here. I would just clear this part. We have already noted it down, or understood. So just remember g is 9.81. So let's just simply solve this question. A is 10 meters per second square, or just say it's 9.81 meters per second square to be more accurate. We f the final velocity right before it hits the ground. This is what we have to find. Right before it hits the ground, we call it the final velocity. We have to find that. So we have to find the final velocity. The initial velocity is simply 0, and the time is 3 seconds. So you can see we are just multiplying 3 by 9.81 initially. You can see that in a case of this becomes 9.81 times 3, which simply means that initially, if you just take it logically, initially the velocity would be 0. After 1 second, the velocity would increase by, since this is free fall, the velocity would increase by 9.81 meters per second every second. This is what acceleration means. So after 1 second, the velocity would increase by 9.81 meters per second. After the second second, the velocity would increase by 9.81 meters per second again, which means this would become 9.81 plus 9.81, giving us 19.62 meters per second. And the third second, it would simply be 19.62 plus 9.81 again, which makes it 29.43, I guess, if we did it correctly. It is 29.43. So even if you multiply this, this is the exact answer that you will get, 29.43 meters per second. The velocity after 3 seconds of free fall, this is the velocity. And no matter what the mass of the object is, you can see we did not take the mass of the object in consideration, since there is no air resistance. So it simply does not depend on mass. Whatever the mass is, whatever the dimension is, height and length, we did not take that in consideration. So it does not affect our result. Now there's a second part to this which says, what can be the height it is thrown? Now we have to find out the height it is thrown, which is this height, or this distance that it has covered in these 3 seconds. So we know of a very good formula that we have been doing earlier. Let's just, this is a very tough decision for me, because just using this eraser stops my pen for a little while. My pen acts like a retard. So anyway, we have to find the distance here. So we know the final velocity. Look, we know the final velocity, which is 29.43 meters per second. We know the initial velocity, which is 0 meters per second. And we know the time, which is 3 seconds. So to calculate the distance, we know our formula says distance is equals to velocity average times time. This is our basic thumb rule formula. Velocity average times time. So let's take the average of the two velocities. So the average of the two velocities would simply be 29.43 plus 0 divided by 2. So this would give me something like 14 point something. Yeah, let's just say this is giving me 14.5. I'm not sure what it would give me. It would give me 14.52 meters per second. So let's just say this is giving me this answer. Just check. I don't have a calculator right now, so just check the answer. This would give me 14.52 meters per second approximately. So now if I need to calculate the distance that it has moved in these 3 seconds, simply I will just put here and put the time, 14.52 times 3. Now this would give me 3 2s are 6, 3 5s are 15, 5 1, 3 4s are 12, 13, 3 1, and 3 1s are 3 4. 43.56 meters. So this height is simply 43.56 meters. So you can see this, that with just the time given, we have calculated all of this. Because in the cases of example of free fall, we always know whether it's stored or not. If they say it's free fall, we always know that the acceleration is 9.81 meters per second square, unless they've told us to consider it as 10 meters per second square, which they do it just for the ease of it, or just making it simple. So guys, I hope you understand this. So if there's any problem, just comment and I'll be replying to them. Thanks for watching. Stay tuned to it.